Welcome everyone. We are going to do part 2 revision class for chapter 2 CBSE plus 2 physics. We already finished up to 10 questions. The 11th question is just reading that question number 11. A dipole with charge minus q1 plus q are located at points 0 minus b 0 and 0 plus b 0. It is present in an uniform electric field E. So we have a dipole that is located in uniform electric field. The equipotential surfaces of this field are planes parallel to YZ plane. So equipotential surface of this electric field lies in YZ plane. So this is, for example, YZ plane. This is Y plane and this is Z plane. Okay. This is question number 11. And then our equipotential surface lie in this plane, like this. So it lie in YZ plane. This is YZ plane, not XZ. It's YZ plane. This is YZ plane. So this is the equipotential surface of electric field E. We don't know the direction of the electric field. Okay, but equipotential surface lies in YZ plane, which means the electric field will be perpendicular to this plane, because equipotential surfaces due to electric field E will be perpendicular plane. So this is the equipotential surface. Therefore, our electric field should be in this axis. Definitely this axis is actually the perpendicular axis to YZ plane. That axis is nothing but x-axis. So this is that axis and this is x-axis. So this axis is x-axis. So our electric field is acting only in x-axis. So direction of the electric field is along x-axis. So our question is, what is the direction of the electric field? So it is along x-axis. So first answer is along x-axis. So what is the second question? How much torque would the dipole experiences in this field? So where is the dipole? Dipole is minus q plus q, is present in this location. 0 minus b 0 is the position of minus q. So I'm just extending this. See, this is y-axis. 0 minus b is this x comma y comma z. X comma y comma z. So this is x, this is y, z. So y is minus b. So just in the opposite direction of this y-axis, I'm just drawing minus y-axis. It will be along this direction. Y-axis minus, this is minus y. And then the location of the charge is somewhere here. The location of the charge is somewhere here. This point is 0 minus b 0. This is the location of charge minus q. And then we have one more charge at this point, 0 b 0, and our plus q charge is here. Therefore, what is the total distance between minus q and plus q? It is from here to here, it is b. From here to here, it is b. And from here to here, it is again b. So therefore, it is 2b. So the dipole now is perpendicular to the electric field, because electric field is along x-axis and our dipole is in y-axis. Okay, so you can see here perpendicular. Therefore, torque will be, they're asking only torque. So torque on the dipole formula is P sine theta. Now theta is 90 degree, because dipole is placed perpendicular to the electric field, and therefore tau is equal to What is P? P is Q into the distance between the two charges, Q into 2A. Here it is 2B. Distance between two charges 2B. So P is electric dipole moment. It is Q into 2B. E sine 90 is 1. So our answer is tau is equal to 2QBE is the torque experienced by this dipole. Okay, so this is the answer of question number 11. Now let us do question number 12. Find out the expression for potential energy of a system of three charges Q1, Q2, Q1, Q2 and Q3 located at R1, R2, R3 with respect to the common origin. So we have three charges now. They are at positions R1, R2 and R3. So let us draw that first. So it take a common origin. Okay, let us take a common origin. So this is one axis and this is one axis. So let us take a common origin. Okay, so this is the origin, and then we have three charges at positions R1, R2 and R3. So that we have one charge here. This charge is Q1, and then one more charge at this point. This is Q2, and then one more charge at this point. This is Q3. So initially I'm just keeping only this charge Q1, which is at distance R1 position, and then now I'm keeping this second charge at position R2 from the origin. So while keeping this, the electric field, this charge will exert force on this charge because of electric field. So the distance will be from here, it will be R12. This is the distance between this thing and between Q1 and Q2. And then similarly, when you keep, so this is the direction of the distance. Similarly, when you keep charge Q3, so it will be like this direction is R13, and then this direction is R23. Three charges. This Q3 is actually a distance in the position R3. Okay. So therefore, I want to find the potential energy. Formula for potential energy is U is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Therefore, for charge 1 and 2, this is for charge 1 and 2, our potential energy will be U1 Q1 Q2 by R12 square, and U2 is equal to 1 by 4 pi epsilon naught potential energy due to 2 and 3. So Q2 Q3 R23 and U3 is the potential. So let me call it as U12, U23, and this is U31, 1 by 4 pi epsilon naught Q3 Q1 by R13. It's R13. So total potential energy will be sum of all these three potential energies. So U is equal to, you can take common 1 by 4 pi epsilon naught, and then you will get q1 q2 by r12 square plus q2 q3 by r23 naught square r23 plus q3 q1 by r13. So this is the potential energy of the system. So this R21 is R2 minus R1. Therefore, U is equal to 1 by 4 pi epsilon naught Q1 Q2 by R2 minus R1 plus Q2 Q3 by R3 minus R2 plus Q1 Q3 by R3 minus R1. So this is the answer. This is the potential energy of system of 3 charges. Thank you so much for watching. Let us continue the 3 marks in the next session. Thank you.